Can you calculate complex probability with multiple variables? Have you ever wondered if you can calculate complex probability when multiple variables are involved? It might sound tricky, but it is indeed possible. Let's break it down in a way that makes sense. When we talk about multiple random variables, we need to consider something called joint probability distribution. This concept helps us understand the likelihood of different outcomes happening together. For instance, if we have two variables, let's call them variable x and variable y. Their joint probability distribution tells us the chances of various combinations of outcomes, like x equals a certain value and y equals another. Calculating probabilities for specific events often involves summing or integrating over these joint distributions. If the variables are dependent, we cannot simply multiply their individual probabilities. This adds a layer of complexity to our calculations. To manage multiple variables, especially when they are numerous or have complicated relationships, we can use several strategies. One approach is to utilize multivariate probability functions. These functions describe how all the involved variables behave together. For example, multinomial distributions extend binomial probabilities to multiple categories, allowing us to analyze more complex scenarios. Another method is simulation techniques, such as Monte Carlo simulations. This approach generates many random samples from the distributions and observes the frequency of outcomes. It is particularly useful for complicated dependencies and distributions that do not have straightforward solutions. We can also look at compound and mixture distributions. These models combine simpler distributions or layers of randomness. Analyzing these can be done using numerical methods or algorithms like the expectation maximization algorithm for estimating parameters. Bootstrap methods are another handy tool. When we do not know the theoretical distributions, we can resample observed data to estimate probabilities and confidence intervals. This empirical approach can provide practical solutions. Calculating complex probabilities with multiple variables is vital in various fields. In finance, for example, it helps model asset price movements. In manufacturing, it assists in estimating defect rates. In risk assessment, it evaluates joint risks effectively. Numbers have cultural and historical significance, reflecting how societies have developed mathematical tools to manage uncertainty. Understanding these calculations reveals how numbers representing not just quantities but also relationships and patterns in our world. By quantifying uncertainty with multiple variables, we can better interpret complex systems and make predictions. This highlights the connection between numbers and the structure of our reality. So yes, you can calculate complex probabilities with multiple variables, and it opens up a fascinating world of possibilities.